Hi everybody. Today we're going to be talking about lesson 10.2, product of powers property. And our job today is to understand how we can simplify problems and problems that specifically involve a lot of multiplication and exponents. Now, unlike what the title says, we're actually going to be learning three different properties, and in some cases we'll even be calling them shortcuts, and you'll see why in a minute. So we're going to start the video. Now, keep in mind that what we're trying to do here is help you understand where these properties or shortcuts come from. So you're going to see a lot of work done out the long way as far as what exponents represent. But then we're going to try to see if we can find some patterns where those patterns are going to help us shorten things up.
So here we've got the problem g to the fifth times g to the fourth. And as we know, exponents is just a way to say repeated multiplications. So here, g to the fifth would be g times g times g times g times g 5 times, multiplied times g to the fourth, g times g times g times g. And whether we write the multiplication with the dots or with parentheses, it's all really just multiplication. So I could just erase my parentheses here and replace them with multiplication symbols. So like this. So in essence, all I really get here is g times itself, 1, 2, 3, 4, 5, 6, 7, 8, 9. G to the ninth. So that's one way for us to figure out what g to the fifth times g to the fourth would simplify down to look at it the long way, to actually represent what those exponents are showing us, and then go to the answer, which gives us a simplified version of that same problem. Now let's take a look at x to the fourth times x to the third. Once again, x to the fourth is just x times itself 4 times, times x times itself 3 times, in which case we get x to the 7th. All right, so what I'd like you to do is these last two the video will pause on its own, and I'd like you to actually do that on these last two, see what you come up with, and as you do, see if you can't establish some kind of pattern or shortcut that will basically get you from the original problem all the way to the answer without having to actually do it the long way. But for at least these two examples, go ahead in your notes, write this out the long way. End of the second times end of the fourth, write it out the long way, figure out what it is, and again, see if you can't find that connection between the problem and the answer. Same thing with the last one, p to the third times p to the fifth times p. Write it out the long way, but then let's see what it turns out to be afterwards. Okay, so in the video, we took a look at multiplication problems with exponents, and hopefully this is what you came up with as you finished your work. You were asked to do these last two, and so end of the second, end of the fourth, we had end of the second times end of the fourth, and we should have gotten end of the sixth. And then here, just being careful that, p to the third, p to the fifth, this is p to the first power. We would get p to the third, p to the fifth, and p to the first. Translate that all together, and it's the variable p to the ninth power. Now, once again, it was more than just finishing these off. We were looking for a shortcut. So in that last slide, you theorized what that would be, and hopefully what we were looking for here was this concept that if you really think about what's going on here, that even though this is multiplication, it's nothing more than taking the exponents and then adding them together to see how many times we multiply our variables. So like here, 3 times 5 times 1 was 9. So we got p to the ninth, and it's a shortcut to skip over all this stuff in between. Same thing on the other one you did. End of the second, end of the fourth, add the exponents, because by adding the exponents you see how many times we're repeating that multiplication. We get end of the sixth. So what we get is this rule in math, which we're going to call a shortcut, that says if you have some number x to the power of m times that same base number x to the nth power, that you can just go ahead and use that shortcut and say it's that same number x to the m plus nth power. So let's try it on a few problems here. Here's our first problem. H to the sixth power times h to the seventh. Now, if we were to do it the long way, we'd have to write this out. H times itself 6 times, h times itself 7 times, and we'd eventually find out it was 13. But why not just use that shortcut and just jump straight to the answer? H to the 6th plus times h to the 7th. We add the exponents. 6 plus 7 is h to the 13th, and we get our answer without having to go the long way. Here's another one. Now, here's where we have to be careful. Just like in the last lesson with exponents of 0 and negative exponents, we have to remember that the exponent only applies to what it's directly touching. So in this case, n to the second power, but this 3 is separate. So you want to see it almost with parentheses like this. 3 times n to the second, 5 times n to the fourth. So that way we don't mix up what the exponent applies to and what it doesn't. And in fact, what I would do here is I'd probably use commutative property of multiplication and shift things around. I'd move the 3 and the 5 next to each other because they're just the normal numbers, and then I'd write down the n to the second and n to the fourth. That way I can work on each part of this problem individually. 3 times 5, like normal numbers, is 15. Don't make the mistake of adding these. We're only talking about using a shortcut where the exponents are added. 3 and 5 are just normal numbers, so 3 times 5 normally is 15. Here's where we add our exponents. N to the second times n to the fourth. Add the exponents, we get n to the sixth. So 15 n to the sixth. All right, let's try a couple more. Now, in the last lesson, we learned how we dealt with negative exponents, but we could do it that way. But in this case, I think we're going to stick to this shortcut and not the negatives exponent shortcut, and here's why. Here we get x to the 8 plus negative 5, because we're just adding the exponents. It just happens to be that this exponent is a negative. But we know how to do this type of math. 8 plus a negative 5 is really 8 minus 5, so we get x to the third. So in this case, we don't have to do the whole thing with the reciprocal here. By using this shortcut, the negative just sort of took care of itself. All right, let's try one last one. Now again, it's all about kind of seeing how many pieces you have. Somebody who just learning this might say this is 2 pieces we're multiplying together, but in actuality, like this problem, we want to see it really as 4 separate pieces. Negative 2 times p to the 7th times 4 times p to the negative 2. So if I first just deal with my normal numbers, negative 2 times 4, and again, I'm allowed to move stuff around because the commutative property of multiplication says I can. And then we've got p to the 7th times p to the negative second. Here, we treat our normal numbers as normal numbers, just negative 2 times 4. Don't mix it up with a shortcut. We're just multiplying here. So negative 8. But then here we've got exponents, p to the 7th, p to the negative second. We add the exponents. 7 plus negative 2, or 7 minus 2, is 5. So we get negative 8 p to the 5th. So that's what we're going to do in this lesson. When you come into class the next day and we work on this classwork, we're going to be applying this shortcut and just this whole idea that even though it's multiplication, what we're doing here is we're adding the exponents.